All right, what's up, stats classes? This is an impromptu video series, two-part series. Most anticipated movie release since Infinity War, Endgame, whatever those are called. I'm not a Marvel guy. I'm going to work through as much as I can in part one, walking you through these problems. And then I'm going to do part two and go as far as I can in two 15-minute videos, okay? I'm doing this because I don't want you to feel stranded. I don't want you to feel like you don't have enough support. Some of you missed class. Maybe this will help you make up for lost time. But I want you to be able to slow me down. You can turn it on 0.75 speed if you want. But let's work through a few of these, okay? Watch, listen, pause, practice, learn, etc. Put the phone in another room. Let's lock in for 30 minutes and get this stuff done, okay? Number one. And I'm going to have my cheat sheet here. I'm going to refer to it. I might call something Rule 6, Rule 5, Rule 4. That's what I'm talking about, is this probability rules cheat sheet, okay, when I say that. Here we go. Probability of A or B. Well, that's an addition problem, so it's going to be the probability of A plus the probability of B. And the only thing I have to check is whether or not I need to subtract a little bit of overlap. And when I see this, probability of A and B being 0.1, that lets me know that there is a 10% chance that they both can occur. So that means that they are not disjoint. So I do need to subtract the probability of A and B. So what I'm using here, and I'll label all of these, I'm using rule number 5. And the answer is 0.26 plus 0.41 minus 0.1 equals, that's 0.67 minus 0.1 is 0.57. I should probably get my calculator ready for some of these harder ones. It's like whenever a math teacher takes out the calculator, it's like a warrior just unsheathing his sword. It's just like, it's go time. All right, so number 2, the probability of B given A. When I see that, I go straight to rule number 8. And rule number 8 tells us that the way we find this is we're going to do the probability of B and A happening, or A and B, it's the same thing, divided by the probability of A. That's straight off rule number 8. So I'm going to try to find that. The probability of A and B happening was given to me in the problem, 0.1. The probability of A happening was given to me in the problem, 0.26. When I divide those, 0.1 divided by 0.26, I get 0.38. Are A and B disjoint events? We already said that they're not. Why are they not? Because the probability of A and B happening is greater than 0. It actually has there's a chance. You're telling me there's a chance. Yes, there is. Are A and B independent? Why or why not? Well, I'll use green to highlight. Oh no, I'll just write it right here. The probability of B given A, we found that in the second part of the question, was 0.38. But check this out. The probability of just B was 0.41. Those are different. Those do not equal one another. The probability of B is not equal to the probability of B given A. Because that's the case, these are not independent. And that, my friends, is question number 1. Question number 2. If the probability of G happening is 0.42 and the probability of M happening is 0.33 and money, they're independent, what's the probability of G and M? So they're literally just asking this, probability of G and the probability of M. It's independent, so it's 0.42 times 0.33. And we get, what is that? 0.14 if you round it. Boom. Let's keep it going. Probability of W is 0.6. The probability of J is 0.34. And then they give us the probability of J given W. So what I could do off to the side, I'm not even going to solve A and B yet, but if I know that the probability of J and W, J given W is 0.2, then I can say 0.2 is equal to the probability that they both happen, W and J, or J and W, whatever, divided by the probability of W, which we actually know what the probability of W is. They gave us that in the problem. It's 0.6. So I can actually, using that, since they gave me this, I set up this formula over here, and I can work backwards and find the probability of W and J, which is actually what A is asking me to do. To find that, I would just multiply both sides by 0.6. And 0.2 times 0.6 is 0.12. Okay, you can also find that by doing this. You can, so that was me over here using rule 8. You could also use rule 7. And rule 7 tells us that we could do the probability of W, which is 0.6, times the probability of J given W, which is 0.2. So once again, you would still get that either way that you did it. You could use rule 8 or you could use rule 7. The next one, probability of W or J. That's an OR problem, so that's addition. So it's either going to be rule 4 or 5. We literally just found out the probability of W and J occurring is 0.12. So there is a chance that they can occur together. So that means we need to, these are non-disjoint. So we need to use rule number 5 for this one. And rule 5 tells us that if you're doing a probability of something or something else happening, you do the probability of the first one plus the probability of the second one minus the probability that they both occur. Okay, we just did that. And the probability of W is 0.6 plus the probability of J, which is 0.34, minus 0.12, minus what we found in part A. So the answer there is 0.74. No, not 0.74. My brain is just dead. That's 9.4.82. Whew. Decimals. Just think money, Smith. What's 94 minus 12 cents? That's 82. Okay, got it. Why can I count money better? I don't know. Maybe it's because I get that money every day. All right, number 4. If the probability of Y is 0.45 and the probability of L is 0.6, and then they give us the probability of Y and L happening. That's huge. I automatically now know that these are not disjoint. They're not disjoint because the probability of Y and L happening is greater than 0. Because they gave it to me right there. Are they independent? We don't know that yet, but we'll know that after we find B. So let's go up and solve these. The probability of Y or L happening. They're not disjoint, so I need to use rule 5, which tells me that I need to add the probability of Y plus the probability of L minus the probability that they both happen together. And that gives me 0.83. This next one, I know immediately, whenever I see a given statement like that, I know that I'm probably going to be using the last rule, rule number 8. And rule number 8 tells us that the probability of L given Y is the probability of L and Y divided by the probability of Y. We know the probability of Y, gave it to us in the problem, 0.45. Do we know the probability of L and Y happening? Yes, we do. They gave that to us in the problem as well. Remember, and problems can go both ways. So that's going to be 0.22. So what is our answer? 0.22 divided by 0.49. We already said they're not disjoint. Are they independent? Well, let's see. The probability of L given Y is 0.49. Let's compare that to the probability of just L, which is 0.6. These are not equal. The fact that those are not equal shows that they're dependent. So these are not independent. Okay, two more. Let's keep rolling for part one. If the probability of D occurring equals 0.32 and the probability of R occurring equals 0.13, hey, and D and R are disjoint. Let's go. The fact that they told us that, we know we just go straight. This is an OR problem, right? D or R, yeah, it's an OR problem. So it's the probability of D or R, and they're disjoint, so we can just add them. 0.32 plus 0.13. Love it when a plan comes together. 0.45. Let's keep going. Number 7. The probability of T happening, the probability of B happening, and then the probability of B given T. Okay. So once again, remember everybody, when you see a conditional like that, you're going to break that down using Rule 8. Let's see what we can do. Here's what I'm going to do. Rule 8 tells us that the probability of B given T is equal to the probability of B and T divided by the probability of T. And because we know that formula, we can work backwards because we have 2 of the 3 parts. We know the probability of B given T is 0.18. We know that the probability of T is 0.51. So we can now work backwards and find the probability of B and T. So whatever 0.18 times 0.51 is, it's 0.09. I'm also thinking, let me test this, 0.51 times 0.18. Yeah, that's one way you get this. You can also just do probability of T multiplied by probability of B given T, which is also 0.09. So you can either use, I've been doing these in red, so you can either use Rule 8, like I did over here, or you can use Rule 7, like I did there. Both get you the correct answer of 0.09. And then last but not least, probability of T or B. Probability of T or B, or takes me immediately to Rule 4 or 5. Do we know if these are disjoint or not? That's the key. It's Rule 4 if they are disjoint, Rule 5 if they're not disjoint. Well, the fact that we said that there's a 9% chance that they can happen together, T and B, that means that these are not disjoint, which means I'm going to be using rule number 5. And rule number 5 tells me that I need to do the probability of T plus the probability of B minus the probability of T and B. So what do we got? 0.51 plus 0.28 minus 0.09. 0.7, 70% chance. Just like there's a 70% chance that you made it to the end of this video. If you did, that's part 1. It really, that's huge. Go watch that again if you don't feel good, because that uses rule 4, 5, 6, 7, and 8, which are the main ones. You understand those problems that I just did on this video here, you're in a great spot to continue. Video 2, I'm just going to pick right up with number 7 once this thing is done loading. Watch this, ask questions, practice, keep working at it.